In this video, we're going to talk about linear inequalities. So let's do a warm-up here by just refreshing our memory about inequalities. So we can say 3 is greater than or equal to 2, or you could say 2 is less than or equal to 3. So the inequality is opening towards the bigger number. You could say 3 is greater than or equal to 3 because this little line under the inequality allows the two numbers to be equal. So similarly, you could say 3 is less than or equal to 3. A -1 is greater than or equal to -2 because -1 is a less negative number, so it's bigger than -2. If we write this the other way, -2 is less than or equal to -1. So a good way of visualizing these inequalities is with the number line. So you've got 0 here, you've got your positive integers going this way, and you've got negative integers going that way. And you can just say the bigger numbers are over here and the smaller numbers are in this direction. So in that sense, -1 is a bigger number than -2. Now let's try solving an inequality that has a variable in it. So what this means is to figure out what set of x values would satisfy this inequality. So let's have two reminders here on what we're allowed to do to inequalities. So first rule is that we can add, subtract, multiply, or divide both sides of an inequality. So you can add 2 to both sides, you could subtract 3 from both sides, you could say multiply both sides by 4 or divide both sides by 2, for example. All of those things are legal operations as long as you're doing the same thing to both sides. But there is a little catch when it comes to working with inequalities, and that is that multiplying or dividing by a negative number reverses the inequality. So let's try to understand why that would be true. Suppose you start with the inequality -2 is less than or equal to 4. So that's true. If you divide both sides by -2, let's see what happens. So on the left side, you would get the number 1. -2 divided by -2 is 1. And on the right side, you'd go 4 divided by -2 gives -2. So look at this, the inequality is reversing. 1 is a bigger number than -2. So the thing we're going to have to be careful about is when we multiply or divide by a negative number, we'll have to just remember that that inequality is going to change direction. And just to have a little bit of intuition for why the direction changes, it has to do with the fact that left and right are reversed on the negative and positive sides of our number line. So if we just look up at our number line at the top of the screen here, for the negative numbers, -2 is further left than -1, but +2 is further right than +1. So because of that reversal, when you multiply or divide by a negative number, you switch the direction of the inequality. So if you had the inequality say 8 is bigger than or equal to 6, you can divide both sides by +2 and get 4 is greater than or equal to 3. That's still true. But if you, for whatever reason, had decided to divide by -2, you would see the inequality reversing. So if we instead divide by -2, we'd have -4 and -3, and inequality reverses direction. So that's one little catch to keep in mind with these inequalities. So let's go back to the problem at hand, which is to solve the inequality 6 minus 2x is greater than or equal to 8. Well, we can subtract 6 from both sides. Adding or subtracting never affects the direction of the inequality, so that just stays the same. And now we can divide both sides by -2. So on the left side, we'll have x. On the right side, when we go 2 divided by -2, that's going to be -1. And the inequality reverses here because we have divided by -2. So in the step where you multiply or divide by a negative number, you're going to see your inequality reversing. Now let's do a second example. Let's solve 3x plus 4 is greater than or equal to 16. Again, our goal is to isolate x. So we could subtract 4 from both sides. We'd have 3x is greater than or equal to 12. Adding or subtracting doesn't change the direction of our inequality. And now we're going to divide by +3. And since that's a positive number, that's not going to affect the direction of our inequality. So we'll have x and 4. X is greater than or equal to 4 would be the solution to the inequality. Now in this section, we're going to be working with the inequalities that involve both x and y. So we want to define what's called the standard form for a linear inequality, and that is where you get y on its own. So the standard form could look like y is less than or equal to mx plus b, or it could be y is greater than or equal to mx plus b. But the simplest way to think about it is just that you've got y on its own on the left side of the inequality, and then your inequality is in standard form. So let's put the inequality 8x minus 4y is greater than or equal to 12 in standard form. So what that means is get y on its own. Okay, we can subtract 8x from both sides. Adding or subtracting does not affect the direction of the inequality. So we're going to have minus 4y is greater than or equal to negative 8x plus 12. And the next thing we want to do is divide by negative 4. So remember, when you multiply or divide by a negative number, the inequality is going to reverse. So I'm going to write down the reversed inequality here, and we're just going to go through and divide each and every term by negative 4. So we're going to have y, we're going to have positive 2x, and when we divide 12 by negative 4, you get negative 3. So y is less than or equal to 2x minus 3. Now we're going to ask, does the point 0, 0 satisfy it? Meaning, does it satisfy the inequality that we were working with in part A? Well, for this ordered pair, x equals 0 and y equals 0. So we're going to sub that into our inequality. Might as well just sub into the standard form. And we're just going to ask whether this is true or not. So we're going to ask this as a question. So replace x with 0 and y with 0. Our inequality would read 0 is less than or equal to, and when we plug x equals 0 in here, the right side becomes negative 3. So we're asking the question, is 0 less than or equal to negative 3? And the answer is no. So that means the point 0, 0 does not satisfy that inequality. Now let's ask, does the point 2, negative 1 satisfy it? So our x coordinate here is 2, our y coordinate is negative 1. And we're going to do same kind of thing, plug this into the inequality, and we're going to ask the question, is this true or not? So just plugging into the inequality that we've got at the top of the screen, y is negative 1, and we're saying negative 1 is less than or equal to, let's work out what happens when we sub x equal 2 into 2x minus 3, so you'd have 2 times 2 minus 3 would be 1. So we're asking, is negative 1 less than or equal to 1? The answer is yes. So the point 2, negative 1 does satisfy the inequality. So now we want to graph the inequality 8x minus 4y is greater than or equal to 12. And this is the main point of this section, is we want to get comfortable with graphing these sorts of inequalities. And that tool we're going to use in chapter 2 to solve some real world problems. So we're just building up our skill set before we get to chapter 2. So I would break this into 3 steps. First thing I would do is I would put the inequality into standard form. And if you remember, we just did that in our previous problem. So let's assume we had already done that. We would get y is less than or equal to 2x minus 3. Step 2 is you want to graph the associated line. So look at your standard form for your inequality and just turn that inequality into an equal sign. So the associated line is y equals 2x minus 3. And we're just going to graph that line. So let's make a quick sketch. We know that line has y-intercept negative 3, and we know it's got a slope of 2. So that means as we take a step to the right, our y-coordinate is just increasing by 2. So we're just going up by 2 each time we take a step to the right. We can just graph a few points on here. So go up by 2 and go up by 2 more, and you get this line here. That's a quick way of graphing the line. So here's a fact about inequalities. The points that satisfy the inequality are on one side of the line. So either the inequality is represented by all the points over here, or the other option is that the inequality is represented by all the points over here. And so we're just trying to decide between those 2 different situations. So the way we decide which side it is, we test any point that's not on the line. So typically the point that we'll choose is the origin, just 0, 0, because it's usually an easy point to work with. So we're going to take 0, 0, we're going to sub it into our standard form for our inequality, which we said in step 1 was y is less than or equal to 2x minus 3. And if that point makes the inequality true, then we know it's this side. And the reason is because 0, 0 is on this side of the line. If 0, 0 makes the inequality false, then we know it must be this side. So just testing a single point that's not on the line is really powerful, and it helps you figure out which side of the line you want to shade in. Okay, so let's plug 0, 0 into our inequality. In other words, we're subbing x equals 0 and y equals 0 into the inequality, and we're asking, does this make the inequality true or false? So y is 0 and x is 0, so the right side reads -3. So is 0 less than or equal to -3? No, it's not. So that tells us how to graph our inequality. So here's our final answer coming up. I'm going to make a new sketch of our line. Remember, we said the y-intercept was -3, and we said the slope was 2. So as we take a step to the right, y is increasing by 2. So there's our line. And we have tested the point 0, 0, which was right here, and we decided that that did not satisfy the inequality. So what that tells us is that all these points over here are the ones that satisfy the inequality. So all the shaded points here satisfy our original inequality, which was 8x minus 4y is greater than or equal to 12. And all the points that are unshaded up and to the left do not satisfy the inequality. So just by testing a single point that's not on the line, it tells you which side of the line the inequality is represented by. So we are going to graph the feasible set for the following system. When we say feasible set, it just means the points that satisfy all of the following inequalities. So what we're going to have to do is just deal with these inequalities one by one. We'll make a rough sketch of each inequality, and then at the end of the problem, we'll put them all together. So let's start with this inequality, x plus 1 is greater than or equal to 0. Well, because this doesn't have a y in it, it can't be put in standard form, but what you might want to do is just rewrite it as x is greater than or equal to -1. And let's think about how we usually graph inequalities. So we think about graphing the associated line. So let's turn that into a line, make it x equal -1. Okay, and if we graph that, that's a vertical line. So there's our line, x equal -1. And then what we're supposed to do is just test any point that's not on the line, and that tells us which side of the line the inequality is on. If we test the point 0, 0, what you're doing is you're putting that into your inequality. So put that into x is greater than or equal to -1, and just decide whether that's true or false. So when I put x equals 0 into this inequality, we get 0 greater than or equal to -1. And we're asking the question as to whether this is true or false. Yes, 0 is greater than or equal to -1. That's true. So that tells us that we want to go in the direction of the point 0, 0. So all these points here are getting shaded. So that was just our first inequality. We're going to do the same thing for the other two inequalities, and then we're going to put it all together into a single graph. So let's look back at the question. Let's work on our second inequality now. So x plus y is greater than or equal to 10. Let's put that into standard form where we just get the y isolated. So you can subtract x from both sides. Y is less than or equal to -x plus 10. And what we're going to do is graph the associated line. So let's try to make a graph of y equals -x plus 10. So just a very quick graph. So that's got a y-intercept of 10, and it's got a slope of -1. So as we take one step to the right, y is decreasing by 1. And after we've taken 10 steps to the right, y has decreased by 10. So we'd be over here at 0, 10. So there's our line. I'm just going to label that right onto our sketch there. And now we need to decide which way our inequality is going. Is it this part here that's sort of down and left of the line, or is it this part here that's up and right of the line? So to do that, we're going to test any point that's not on the line. So often I'll use 0, 0, but it can be any point that's not on the line. So just to make the point, I'm going to say, let's test the point, let's say 1, 1. As long as you're getting something that's not on the line, this will work. So 1, 1 is right here, and we're just deciding whether that satisfies the inequality or not. So let's put that into our standard form. So y is 1, and x is 1. So the right side is going to be -1 plus 10, which is 9. Okay, and we're just asking, is this true or false? Well, yeah, that's true. 1 is less than or equal to 9. And so that tells us that we do want to go in the direction that contains 1, 1. So we want to shade all this stuff here. So that's our second inequality done. And then we've got a third inequality. So let's look back at the question. Third inequality, -x plus 0.5y greater than or equal to 0.5. So we'll work on that one and then we'll put it all together into a single sketch. So we're going to get this inequality here into standard form. Let's add x to both sides. And then let's multiply by 2 just to clear the 0.5 here. So 2 times 0.5 is 1. Therefore, we've just got a y there. Multiplying by 2 all the way across, you'd have 2x plus 1. So that's the standard form of our inequality. And what we're going to do now is just graph the associated line. So let's graph y equal 2x plus 1. So that's going to have a y-intercept of 1, and it's got a slope of 2. So as you take a step to the right, y is going up by 2 units. So there's our line. And I'll just label that right on our sketch, y equal 2x plus 1. So now we just need to decide which way is the inequality going. Is it going sort of up and left, or is it going down and right? So for that, we're going to test any point that's not on the line. So let's say test the point 0, 0, which is right here. We're going to plug that into our inequality and decide whether it's true or false. So just plug it into the standard form of your inequality. So y is 0 and x is 0, so 2x plus 1 is 0 plus 1. So we're asking, is this true or false? Is it true that 0 is greater than or equal to 1? No, that's false. So what that tells us is that we're not going in the direction that contains 0, 0. We're not going down and right, therefore we must be going on this side here, the up and left side. So that's that third inequality done. So I'm just going to scroll back to the question for a second so we can see the wording. The question was graph the feasible set for the system. So what we're going to do now is create a single sketch that contains all 3 of these lines, and we're just going to figure out which region satisfies all the inequalities. So I might do our answer right over here just so that we can see all of our work. So our first inequality was formed from the line x equal -1. And we said we were going to the right of that line. So for now, I'm just going to use an arrow rather than shading until we get all of our lines on here. So that was one of our inequalities. Let's look at our second one. So it was formed from the line y equals -x plus 10. And we were going sort of down and left from that line. Okay, so let's put a little bit of scale on here. So let's say this is x equal 10. And let's say y equal 10 is up here. So our second line had a y-intercept of 10 and an x-intercept of 10. And we were going sort of down and left from that line. And then let's see if we can get our third inequality on here. So the third one is the one that we've got on our screen right now. We had the line y equal 2x plus 1. So that had a y-intercept of 1 and a slope of 2. So our line was doing something like that. So there's our third line, and we decided we were going up and left from that line. So now I've labeled all the x values, all the y values, just in case you're interested in making a really careful sketch here. And the point of the problem is that we now want to shade in the region that satisfies all the inequalities. So we need to stay to the right of the red line. We need to say down and left from the blue line, and up and left from the black line. So let's try to shade in all the points that satisfy all of these inequalities. I'll do the shading in blue. So we got to stay right of the red line, sort of above the black line, and below the blue line. And we're getting this triangular region. And so that's called our feasible set. It's the points that satisfy all inequalities. And it's often helpful to have your lines labeled. So there's our feasible set for those 3 inequalities that we started with. So let's just do a little bit more practice with putting an inequality in standard form, since that's something that we need to do in order to graph an inequality. And for this one, we've come up with some particularly tricky numbers because we've got these decimals in here. So let's find a good way to deal with this. If you see decimals like 0.3 or 0.4 in an inequality, a good thing to do is just multiply the whole inequality by 10, since that will clear the decimals. So we're just going to multiply every single number here by 10. We'll have 3x minus 4y is less than or equal to 20. And since 10 was a positive number, that doesn't change the direction of the inequality. Now we're going to try to get y on its own. So let's subtract 3x from both sides. Subtract 3x, we get minus 3x plus 20. And then what we're going to do is divide each term here by negative 4. So remember, when you multiply or divide by a negative number, that's going to change the direction of the inequality. And if you want to do this step by step, what you can do is just show yourself dividing by negative 4 and then work out the algebra in the next step. So each and every term here has to get divided by negative 4. And again, our inequality has reversed there because we've done that division by a negative number. So on the left, negative 4y divided by negative 4 just gives us y. Negative 3 divided by negative 4 gives us 3/4. So you could call that 3/4 x. And then 20 over negative 4 is negative 5. So there we go. We've got the standard form for our inequality. So final thing I wanted to mention is just something about the course pack. Caution here that the course pack shades inequalities in the opposite way. So if we talk about the inequality, let's say x is greater than or equal to 3. Our method that we covered in the notes and in this video is that we shade the points that are included in the inequality. All these points satisfy the inequality. Now the course pack does this backwards. The course pack method shades points that are excluded. So the point of view of the course pack is that they're sort of throwing points away. They want to throw these points away. Well, the course pack method works fine when you're working with a single inequality, but when you go and put multiple inequalities together, this idea of throwing points away doesn't work very well. And so just be aware that when you're checking your answers for section 1.2, the course pack is going to look backwards to what you're drawing. And as long as you keep that in mind, that should avoid any confusion. So suppose we're graphing a feasible set, and let's say we have 3 inequalities. Let's say one's going sort of this way, one's going like that way, and then let's say we have another one that's maybe going this way. Our method shades in the points that are included, so we would just have this triangle shaded. Whereas the course pack, if they were solving the exact same problem, and I'll try to draw the exact same kind of setup here, they do it like this. They say, okay, we're going to throw away these points here because we want to satisfy this inequality. And then they say, okay, we're going to throw away these points here because we want to satisfy this inequality. And then they say, okay, we're going to throw away these points here so that we can satisfy this inequality here. So in the course pack, the feasible set is going to be the triangle that's unshaded. And in our method, it's going to be the triangle that is shaded. So you can use either method. I won't be picky about which way you do it. I just want you to be aware that when you're looking at the course pack, they will be doing their drawing slightly differently than the way we did in our notes and videos. So either way, the actual answer is the same. The feasible set is the set of points that are inside the triangle. So that's our video on linear inequalities. Thanks for watching.